called in. They called in consulting engineers, they called in economists, they called in some sociologists, and we presented our fairly detailed report to them, answered a whole series of questions over a number of meetings, and finally the consensus was that Flinders car was worth a try. Letters from all over the world, from Japan, from the USA, from Europe, right throughout Asia, Thailand. We've had them even from West Africa. We've had sort of interest in this car, I think, everywhere, which sort of shows in one sense a need for a viable car, and that certainly surprised us.
The Flinders University electric car is an experiment. An attempt to overcome the problems which have made other electric cars unsuitable for everyday use. Its success or failure depends on how well the problems are solved, and this rests with John Atkinson and the other members of his research team.
When we decided to build a car, then the enthusiasts, the whole group decided that we'd have a car, and then it was the people with the ideas and the enthusiasm, they came forward. Darryl Whitford, his ideas finally won the day in convincing people that they were the best ways to assemble components.
When we looked at all the electric cars available in the world, we found that they didn't meet the requirements which was required of them today. So that we looked at perhaps another way of building a car to overcome these problems.
What was wrong with the other electric cars that were being made around the world?
Two basic reasons, I think. One is the fact that they tend to be very heavy for their size. This is mainly because the only viable source of stored energy is the lead acid accumulator. And also the fact that when they were used under urban conditions where you experience a lot of stop-starts per mile, accelerating to a reasonably high speed in between, the range was so low that they were virtually useless to most people.
Another man had ideas about building a body, a light body to put into the car, and so the thing was very fortunate. It came together basically from people on the staff, although we have recruited one man from outside since it started. This is a commuter car. It's a car that's used in the cities to do 50 and 60 mile start-stop traffic. So one of the first things that you've got to consider is all the drag factors, the wind, which is very important. The shape of the car is terribly important in an electric car. Because wind resistance is a very big factor in holding back any car. The weight is terribly important. You've got a factor that's about 15 pounds per 1,000 pound of weight drag in any.
So that's the end of that. That was somebody put that on the internet. They found it on a tape on a machine that they bought and put it on the internet, and we found it. So this is what happens when we don't have another guest speaker. You get to hear me talking about this again. But Sally had this really good idea to get the car going for the national meeting this year, which sounds easy. It's turning out to be very, very involved. And for those that don't know anything about the car, the reason it's so noisy on that video is that it's actually what they call hydrostatic drive. So its electric motor runs hydraulic pumps, and they run the rear wheels. So it's actually hydraulically driven. Well, the whole car is not a mini moke, as a lot of people think. It was all completely built from scratch down at Flinders Uni. And it was built in 3 distinct sections. There's, from there forwards is one section, unbolts. From there to there is the middle section, which is where the batteries are in there, and the rear section, and that unbolts. And their idea was that they could change any part of the car easily by bolting a new section on. But it never happened. That was the only one that ever got built. So my involvement with it I did get a lot of drawings, original drawings with the car, and I've had a lot of help from Viv Rush, who was the mechanical engineer, and Darryl Whitford, who did the electronics and the hydraulic design. So Viv, as people know, lives here in Adelaide, but Darryl's up in Townsville. So I just email photographs and have put my list of questions, and he sends back the answers. So this is the basic idea of the car. There's your motor. You've basically got a contact, a 144 volt battery, and that motor just runs flat out. So you've got your various electronic bits, and the accelerator pedal puts a signal into this electronic circuit, which puts a signal out. And this unit here does it's sort of the heart of the thing, does the electric to hydraulic conversion. So as you put your foot on the accelerator, there's two valves here. One opens, allows hydraulic pressure to come from the pump to your motors, and the other one releases the pressure. So without that, nothing will happen. So there's a motor on each wheel, and there's a gearbox, which is 8-to-1 reduction, which was all built, cast and everything in-house. All the mechanical stuff is all based on a Mini. It's all rubber cone suspension. So the plan for the car was to get it going, was to do it piece by piece. So prove that the hydraulic parts work. So in other words, if we could get the motors to run, prove the electronics are okay, and then put the two together and see what happens. But the whole car, it's rather than a restoration, it's more of a conservation. My idea is not to alter or damage anything of the original car that I can, so that if people look at it in 10 years' time, it'll look like it did then, when it was built. Just not so pretty. But I've done cosmetic work on the outside, and got rid of rust and stuff like that. So if we start with the electronics. Luckily, I've got the circuit diagrams for most of the electronics. The heart of the thing is this: the whole electronics runs on 144 volts. There's an inverter unit here, which converts to 12 volts DC and 12 volts AC and 30 volts out the inverter unit. That goes into the main control unit, and that's where the inputs come from the accelerator, and there's your motor circuitry there, the contactors, but everything runs straight off the 144 volts. So that's the inverter unit. There's current measuring, there's pressure. I haven't found out what these are about yet, pressure in and pressure out. Accelerator input. The accelerator is basically a pot. And on the output, you have two solenoids, 1 and 2. One puts pressure into the hydraulics, and the other one releases the pressure from the hydraulics. That's for all the circuit boards. They're all designed and built down at Flinders, and they just plug into this main unit. There's like a motherboard at the back, and there's a massive transformer in here. The thing weighs a tonne. The circuit boards, when I got them, there was a lot of rust, which I've never seen rusty circuit boards before. Rusty transistors. So all of this has been cleaned up, and I've put this clear lacquer on them that you use on circuit boards. The electrolytics, I expected them to be pretty not well, and they weren't. After 50 years, they tend to deteriorate. So I've replaced them. These are hard to get with leads at each end, and I think they were 500 volt ones. But Eric sourced them for me from Sydney. So we got them and replaced them. Dashboard removal. it was rather difficult to work out how to do this. So Viv Rush came up and actually gave me a hand. He built the thing originally, so he knew how it came apart. So the reason I needed to take it out was to get this out, so I could get a key that would fit this and take the tumblers out, so I could actually just use the original lock, because it doesn't need to be very secure. But to get that out, now I know there's some method of clearing plastic that looks like that, so I'd be, if anyone's got any clues, I'd be interested to make it clear. Yep. So the dashboard, like everything, is built like a tank. The whole thing's enclosed in this box. So as it started to come out, the steering wheel got in the way. So that's a view behind it, and everything's just plugged in with spade connectors. So when I do get it out, I'm going to be very careful, make sure everything's really labelled and lots of photos. Yeah, the other thing I discovered was a very rusty piece through here, which I'll have to deal with once that's out. So the motor and the pumps. That's the original motor, which bolts in at 4 corners. That motor was taken out of this car and put in the next one they did, which was a converted Fiat, and they actually used 2 of these motors on the same shaft. So that motor will never come back to this car. But luckily Edward had one just laying in his shed, which turned out to be absolutely perfect for it. The original motor was, hang on, where is it? Original motor was 5 kilowatts and it ran at 3000 RPM at 144 volts. Well, this one, if I run it at 60 volts, gives me 5 kilowatts at 3000 RPM, so it's just perfect. So I ended up making a plate that bolts onto the original mounting points where the original motor was. So I didn't have to change anything on the car. I just had to machine that up. So that was mounted on the plate and just made up a shaft that matched the original. It's the original pulley off the thing. Put a keyway in it, and these 2 bolts, the actual hydraulic pump itself is on a aluminium frame that they've made that sort of is like that shape. The bolts, these bolt and actually hold the pump in position. So that's it in position, and the pumps are over that side. So that's the 2 pumps. So this one's directly driven. That's the one that supplies the pressure to the 2 motors. And this is what they call a control pump. So this one supplies pressure to that box I was telling you about that does the electric to hydraulic conversion. And we'll get to that. That was a gold-plated fan belt that I needed to run the 2 pumps, because the second one runs off a belt off the first one. It was $28 for this little belt. Before it went down to Flinders on display, a friend Ray and myself, we got into it with a pressure washer, and because there was just oil everywhere, and got rid of this horrible looking thing. Nicely made, but not original. And so, working from photos, I made up a new panel for the back to match what was originally there. So that was on the car, and basically cleaned everything up on the outside, so it looked good. The seats, I took them to a motor trimmer because they look great from that angle, but they don't look so good from the front where the sun's really got to them. They're Toyota Hilux, early 1970s. The back of them was extended by Viv Rush to make high back seats. So this material looks blue, but it's actually got a black fleck through it. And there's nothing that's remotely similar to it, because I was hoping just to get these redone. So basically, to get the whole lot redone, that's about $1,500. So they're going to just sit there for a while, get it going first. Then we looked at the hoses and pipes and went, oh dear, there's hoses and pipes running everywhere. I've had to replace this one because this one had shrunk. So when we put oil back in the tank, it started running out every time we moved the other end of it, because it had just shrunk over the years and there was nothing holding it on. So this one's the same, so that'll get replaced too with the same stuff. That's the filter. I managed to buy another filter today, which was quite amazing. They still make them to fit. But there's bits all over the car, which there was bits that have been put on top of other bits, as they work through different ideas on the car. So there's a lot of redundant stuff and a lot of redundant pipes that don't really need to be there. And when you look at it, there's just stuff going everywhere. And trying to work out what each one of them did, it was like trying to follow it through was just about impossible. So we know now that that's the return for all the other pipes. It goes from there back into the hydraulic tank. That's a block there that they brought a lot of pipes into, and that's ported so that some join others and not others. But we don't really know what's in there. Now this is the unit that does all the hard work. So the electrical signal comes in there. This is when it was built. That's the two valves that put hydraulic oil pressure into that. And then that, as that operates, that pushes a piston up in here, and at the same time operates the slider on this pot. So that's how it was when I pulled it out the car. It was a bit grubbier. And on this end is basically a master cylinder that they've created. They've machined it out of aluminium. And that operates 3 slave cylinders. So that's the close-up of the valves. When we did start to test it, we put pressure on the valve that put the pressure into the unit, and it moved a bit, but not really, but a lot. We could see oil going back through the return line, which it shouldn't have been doing. So I got onto Darryl Whitford, and he said, oh, it's because that one's a normally open valve, so you actually have to put power on that to close it off, so the piston won't build pressure until that one's operated as well. So that one opens, lets the pressure in. This one you have to put power on to stop it going back. So the reason they did that was that if it failed, this would be, and there was no power on it, it'd be normally open, the pressure would come out of the thing so the car wouldn't keep taking off. So it was a safety thing, so it would always go back to zero. Those, if we go back, they're mounted on little rubber grommets in each one of those. There's 4 of them. I couldn't buy any that had the right size hole, so I just bought some blank ones and then used a leather punch to punch the hole, and then I could put them back together. But I found that there was only 3 of them. When I pulled it apart, there was only 3 screws used. This one wasn't used. And when I went back to look at the original photos, that one wasn't in there then because that hole's stripped. So it was stripped in 1972. So I only ever had 3. That's the master cylinder bit that sits on the end of that other cylinder that operates the 3 slave cylinders. And that's the internals of it, which were totally jammed up. So I've got a replacement kit. It's a standard master cylinder kit. don't know what sort of car, but the brake people seem to know what it was, so I've got the new rubbers for that, new kit. So the slave cylinders, that's it there on one of the motors. That's the motor there, can't see very well. So as the slave cylinder operates, it operates this lever and allows pressure to go to the motor, so it'll drive the wheel. So it's one of them on each wheel, but we couldn't get any pressure, so because we haven't had this part of the circuit working, and then we discovered that there was one here that operates the pump that drives those pumps on the wheels, the motors on the wheels. And until this is operated, there's no pressure comes out this pump. So that's where we're at the moment, is I've got all the bits to fix this part of the circuit. So once that's operated and those three operate, the wheel should turn. So that's the plan. That's the unit pulled out, because I had to pull the whole thing apart and make sure it was all right, because it wasn't working properly. Really nice machining on it. That's the inside of it. So it's just got one seal that goes up and down, a couple of return springs. And that was in perfect condition, and the cylinder is just aluminium, there's not sleeved or anything, and that was in perfect condition. It's just the hydraulic oil lubricates it. That's the piston that pops out the end that operates that master cylinder. And that's the box. Got rid of all the rust on the box and replaced all the rubber grommets on the outside. So the electrical side of it, when I pulled it apart, that's the slider pot that goes up and down, absolutely covered in oil. That is a fixed pot where they set the adjustment and lock it off so that it operates within the slider operates within the right range. And that was also in the box, which is a current shunt. But I've no idea how that's wired in yet. That's the plug that goes on the outside of the box. It's what they call an octal plug, which is very popular back in the 60s. Covered in oil at that stage. So I ended up pulling the whole thing apart and cleaning it all, painting it all, and yeah, that's what it looks like now. I've actually got the unit here. If you want to come and have a look later, that's the actual unit there. So that's your two valves, the hydraulic part, and then the piston comes up here, and that's basically the master cylinder part, which goes on the end, goes in there. So all the wiring on the whole car is in absolutely brand new condition. So that's one thing. All the insulation's great on it. So what I've done is just made up a test lead which plugs straight into that plug. I've got a pile of old radio valves at home, and I've picked one that was looking a bit dark, knocked it off and got the plug off it, so it fits straight in. And I'll just use some push buttons so I can actually operate these two units manually. So we should be able to theoretically sit in the car, one person steer and the other one operate these, and that should actually make the car drive. If we get that far, and from there we can then get the electronics working that the accelerator actually controls it. So it's, oops, didn't sound good. Yeah, so I've had a lot of help with it. It's been great from Viv and from Daryl, the original people that ran it. Edward for the motor and Eric for helping me with get the electronics, and my mate Ray, who's been coming up and doing a lot of work with me. Two heads are better than one, so they say. So, any questions? Oh yeah, I've actually got there is a video of that unit working just using compressed air. So it'll give you more of an idea. So yeah, if we can see, get that running. It's only short, you might want to play it a couple of times.
Thanks, Microsoft.
Yeah, so I'm just putting compressed air into that cylinder. And that's the bit that operates the master cylinder part. And you can see that's operating that pot, slider pot. Yeah. Yep. So that's it. Yes.
You want to go?
I was just going to say, can you remind us, after the program finished, how did the vehicle get left to deteriorate so much?
It got, after it left Flinders, it went to Burwood Mill for a while, and then they sent it back to what was the Department of Mines, who actually supplied the money for this whole project originally, and it got left out outside. It then went to a couple of people, and it got left out, and one of the people lived down by the sea, and so it was left out in the open. But I've had issues with a couple of these pipes, this return pipe. It's beautiful and flexible where it's not been out in the sun, but where it's been exposed to the sun, it was just brittle. So I've got you can still buy this stuff. So it'll look just like the original, but it won't have a hole in it. Yeah.
Yeah, I was going to say, I used to work on a lot of Bobcat stuff, which was much hydraulic based, obviously diesel in those days, but
Yeah.
I always thought about having an electric drive. As soon as I heard the noise, I heard
Yeah.
Bobcat motors. Yeah,
Yeah, it's very noisy.
It
Yeah.
took me back 30 years. And my twitch started again. But also, I'm just interested though, with the hydraulic drive, did anyone ever do an efficiency test? Like, how
They have.
I'd say how inefficient was it?
Yeah.
How efficient was it? Did they ever look at that sort of stuff with
They
it?
did, yeah. I've got several reports which are like this thick,
Yeah.
sort of being a university, they've got to keep putting out generating reports. And there's graphs and stuff all through it, which I haven't got to look at all of it, yeah.
So if you had to-
But yeah, they have, they've looked at all of that. And
yeah. 'Cause I can't imagine there would be much more. Like
no,
More than 50%,
No.
probably 30%. Yeah.
I think the main reason they did this like this was because in 1972 you couldn't get electronics that would handle the current.
It's
Yeah,
step type,
yeah,
acceleration
Yeah.
and resistor type pack.
yeah,
Looking at the electronics.
yeah. Yes.
So in the video it said that the countries wanted the product. Was it because the product didn't take off because it was too complicated, or was it because it was too costly?
The whole thing was too complicated and it just didn't work well enough. And by that time they'd gone to pure electric drive. Yeah, it's just too complicated. Yeah. Nice idea at the time, but certainly unusual. Yeah.
What sort of hydraulic oil will you use?
I'm using stuff called Superhydraulic 32.
I don't know if you've heard of Tellus, is it T-E-L-L-U-S? That, I used to work at Mitsubishi Motors. We used a lot of it in the machine shop.
Oh, yeah.
Quieting down hydraulic noise. It was
Right.
quite effective.
Right.
It's like something you can look into.
Yeah, so at the moment we're at spend the least amount of money and try and see if it's actually feasible to get it going. Yeah. And then we'll go back and make it reliable. Yeah. Yep. Okay.